Good morning, students. In previous class, we have discussed about introductions and case studies, introduction of big data and case studies of big data. Okay, so now in this class, we will discuss about the Hadoop for big data. What is that Hadoop concept? Okay, so here we have discussed about only about data. So how we will manage data? For that, what we tool we need? Okay, so that concept we will discuss in this today's class. What is Hadoop? Okay, so Hadoop, that one we'll call it as a Apache Hadoop. Apache Hadoop is an open source software framework that supports a data intensive distributed applications and licensed under Apache version 2 license. So yeah, this Apache is nothing but it is a open source software framework for data, big data. Okay, so here you already know that a software framework, it is a platform where we will have n number of tools and platforms are available, okay, to develop a software. Okay, so here a number of tools, that is nothing but in big data framework. Okay, in big data Hadoop framework, we will have a number of tools. Okay, and we'll have different visualizations. Every tools are also available. So everything is available for to manage the big data. So here Apache Hadoop is a software open source software framework for big data. Okay, so that it supports, that is data incentive distributed applications and licensed under Apache version 2. That is, will have a number of applications and tools are available to manage the big data. So here big data is, if it is big data is there, then obviously Hadoop will be available. So that is, Hadoop is, it is a software framework for big data. Okay, so it contains a number of applications and tools to manage the big data, to create and manage the big data. So this Hadoop was created by Doug Cutting and Mike Caffarella in 2005. So these are the two scientists, they have developed this Hadoop. Why they are giving this Hadoop? So when he invented this Hadoop framework, now, so at that time this Doug Cutting son is having a elephant, okay, elephant eye. So that's why he has given the name as Hadoop. Okay, so you can see anyway, you can see the pictures of that Hadoop framework. So elephant is there. Okay, why he is giving elephant? When he is invented, at that time his son having the toy, elephant toy on his hand. So that's why he has given that name to that software framework Hadoop. Okay, so that is the name it after his son toy elephant. It was originally developed to support the distribution of Nudge search engine project. So initially that Nudge is like your Google now. So like that Nudge is one search engine in US. So for that, originally it was developed for to support distribution for that Nudge software, search engine. So for that they have developed this one. After that it will become a popular for big data. Okay, so here this Hadoop is an always same thing. Our Hadoop is an open source project initiated by Apache Foundation that enables the processing of large data sets in a distributed manner. Okay, when data is distributed on a number of clusters or nodes, so at that time, so here large data set we can store in a single place. So we can store the data will be distributed among multiple places. From that multiple places, the data can be processed. Okay, so that one we will call it as a in Hadoop framework. It is an open source project initiated by Apache Hadoop that enables the processing of large data sets in a distributed manner. Okay, it enables the processing of large data set in a distributed manner. The core of Hadoop mainly consists of two things. Okay, it contains two things. One is MapReduce, another one is Hadoop distributed file system. Okay, so MapReduce and Hadoop distributed file system. It's Apache framework. It contains two things: MapReduce and HDFS, Hadoop distributed file system. So this MapReduce is nothing but processing of the data. HDFS is nothing but to store the data. We have some platform. So to store, we will have Hadoop distributed file system. To process the data, we will have MapReduce. We will discuss what do you mean by MapReduce and what do you mean by Hadoop distributed file system. Okay, so MapReduce is a it is mainly used to process the data. How we will process the data? So we'll have some rules to process the data. So here MapReduce is a framework or a programming model that allows carrying out tasks in parallel across the large cluster of components. Okay, this MapReduce is a framework or a programming model that allows carrying out tasks in parallel across a large clusters of computers. It mainly consists of two functions, namely map and reduce. So here when data is distributed or stored among multiple clusters and multiple systems, so to process those things at the time we need this paralleling. That is very important. So parallel when you process the data among multiple clusters, so at that time this map reduce is very important. How it has main two things. One is map and one is reduce. What is map and what is reduce? Okay, so here what we have, we will have a input data. Okay, so input data, each input data will have a key value pair. One key is there, for that we will have a value, key value pair. Every data will have a key value pair. So what we are doing, we will map the key value for the data. So then after that, once we are mapping the key value, then after that we sort the data based on the keys. Okay, so I will take one example. Okay, so here what we are doing, so here we will assign the key for each value. After assigning the key each value, each key to a value, then after that we will sort based on key. Okay, so we will start based on key. So in hand here, so for each key how many values we have, count will be made it. So that one will be the output. Okay, so here I will take an example. Okay, here I have an example. See here, we have a one file input. Hello big data everywhere. So here three words are there, three words are there. So this is the input file. So here we will map, we will assign a key for each one. So here that is key is nothing but here how many times it is repeated in this. Okay, so hello is one time, big is one time, and data is one time. Okay, hello is one time, big is one time, and data is one time. Like that in file to big data everywhere. So here big is one time, frequency we are making a frequency. So this is key is hello big data, where hello big data is value, and one is the frequency. That is one is nothing but a frequency is nothing but a key. Okay, so here big is there, data is there, everywhere is there, everyone. Oh, big is one time, data is one time, everywhere one time. Okay, so then after that we need to shuffle. So shuffle what you are doing, so shuffle is nothing but you combine wherever common values are there, you are combining those things. Okay, so here hello is, it is only one time, so we can hello is done. See here big is one in one file, one in one file, big one time, and another big is another file. So here same value is there, so frequency is one. So what we are doing, those frequency I am writing in one place, big, and I am combining those big and how many times, one this one time, and the frequency one time. Like that we have data is also one is there. So I am shuffling that, this I am combining the common values. Okay, that one we will call it as a shuffle. Data is one time, everywhere is one time we have written. Okay, so now we have mapped the frequency. So then after that we have shuffled the values. Okay, so if it is same thing, we are shuffled to one place. Okay, and we have written that frequency also. So then after that what we are doing, so here in reduce function what we are doing, so that frequency will be added. Okay, instead of writing one time, we have added 1 plus 1, it will be 2. So that one will be reduced. Okay, so here allow is one time, and big is one, that is two times, and data is also two times, and everywhere is one time. So this is the reduce function. Okay, map function and reduce. See here map and reduce. See here how many files are there, here two files, and here when you are mapping we have the 6 words we have. When we reduce, when you shuffle, it becomes 4, and when your frequency are frequency is also there. So here when you come to reduce, here we have value and frequency is also added, and we will get a so final frequencies of how many hello is one time, big is two times, and data is two times. So this is, we will call it as a reduce. So this is, and after that same thing we will put for the output. Okay, so same thing will be put for the output. Reduce. Okay, so here what we are doing, that is map and mapping the frequencies. Then after that we are combining the in shuffle, what we are doing, combining the same values in one place. So then after that what we are doing, we are reducing the frequency. That means we are adding the frequencies. So then after that we are putting the output. So this one we will call it as a map reduce. This is one example. Like that, this map reduce functions will work, mapping the frequencies and after that reducing the frequencies. Okay, so in between we will have a shuffle. We are combining the same values in one place. Okay, so this is an example of map reduce. Like that, another one example. So here date and dates we have 1/1/23, 2/1/20, sorry, or 2013. Like that, we here we have a values, dates we have. So here what, how we will apply this map reduce function. So here this is the file, actual file. Then after that here we will count the, so map function, in map function, so how many times it is repeated. Okay, so we are combine the frequencies. Okay, so we are identifying the frequencies. So then after that in reduce. Okay, so here if it is same thing, so instead of here we have written directly a shuffle, we have not done directly, we have reduce. Okay, only map and reduce now. So in shuffle is in between. So here we are combining the frequencies, that's all. 2/1/23 here, 2/1 uh, 2/1 2013, 2/1 2013. So two times like that we have combined. So that frequencies will be reduced. Map will identify the frequencies, and reduce we will add the frequencies. Map will identify the frequencies. Reduce we will identify, will add the frequencies. Like that, this map reduce framework will work. Okay, what is the architecture of this map reduce framework? Since map reduce frameworks, we have two things. Okay, so that is job trackers and okay, sorry. So here we have job trackers and task trackers. Okay, so here what we have four components. We have, one is client. Client will submit the jobs. So yeah, I have, I told us all these numbers. I am giving that job to that job tracker. So here job trackers and task tracker, two things are there. So client will submit the job to job tracker. Job tracker will track the, accept the jobs from the clients. Okay, so here, so this is user interface submitting the interface for submitting the jobs and post status information to client. That is what a clients will submit the jobs to job tracker. So job trackers will call it as a master. Task tracker we will call it as a task. So job tracker what is like a head. He will insist to do this work. That's all, and he will manages all the administrative work. Like that. That is the things. Okay. So job trackers and task trackers. Okay. So this job trackers, what it will do? It will accept the jobs from client. Okay. So that is accept the MR jobs. That is map reduce jobs from the client. Client, it accepts the job. Okay, so then what, that job will be divided into a task, and task is assigned to slaves. So slaves is nothing but a task tracker slaves. Okay, and monitor the tasks and handles the failures. This is the functions of job tracker. Okay, it won't do any job. Okay, just it will assign the jobs and monitor the jobs. If any error found, it will identify and it will enter the errors. That is the job of job tracker. Okay, so here client will submit the job, then job tracker will accept the jobs. So then after that he will assign the task. The job will be divided into n number of tasks. This task is assigned to slaves. Okay, so once the tasks are assigned to slaves, then monitor the tasks, how that jobs are going on. That is how tasks are going on. Then how the tasks are going on, then after that how when something is errors are getting, so then he need to handle those errors. These are the four jobs of job tracker. He is the master. Okay, when you come to slave is nothing but a actual. Slaves are nothing but a task trackers. Actual map reduce job will be done by this task trackers. Okay, so here it will run the map reduce tasks. Task trackers it will runs the map reduce task and manage intermediate output. Sorry, manage intermediate output. So then after that it runs the map reduce functions and it will progress the report. So here it will manages the intermediate output. So here we have a task. This is the actual task. It will runs the map reduce functions. This task is like client will have for the slaves will have a task. Okay, what is the task? Task is nothing but it runs the map reduce functions. Okay, so task is actual task is doing. The task tracker will this place will do the task. The task is nothing but runs the map reduce functions and report progress. Then after that functions, it will report the functions. Okay, so this is the so here job trackers it will assign the job to task trackers. The task trackers that is nothing but it is a slave. It will do actual tasks. Okay, so this is the an architecture of map reduce architecture. Okay, yeah, so in example they may ask what is the explain the architecture of map reduce architecture of map reduce. So here job tracker, task tracker, client will submit jobs to job tracker. So then job tracker accepts the job, and then after that it will assign the task to task trackers and it will monitor the tasks, and after that it will hand us the failure. When you come to task trackers, it will runs the map reduce task and it will manage the intermediate report. And here the task it will runs the map and reduce functions and it will reports the progress. Okay, so this is the architecture of map reduce. Okay, so here this is a framework how it will same thing, that is architecture. This is a framework. So here we will have a Hadoop distributed file system. So in that we will have actual data. So here what will be, client will submit the job. Okay, so client will submit the job to a job tracker. This is the job tracker, this is the task tracker. So then what it will do, so once it submit the job, then job tracker will divide the job into task and it will assign the task to a number of task trackers. Okay, so it will assign, job tracker will assign the jobs task to task tracker. This task tracker is having the task that is nothing but a map reduce functions. This map reduce task tracker will executes the tasks. Okay, and it will send the okay intermediate output of the tasks will be sent to the this is the task submissions, and output of the task will be submitted to job trackers. Okay, so we may get intermediate results, then after that finally we will get a final result. Okay, after execution of all the data, so we'll get a final result, then final result will send to clients. Okay, so this is the map reduce framework. So here also same thing, client, job tracker, task trackers. Okay, and task is nothing but a map reduce function. Okay, so this is the framework of map reduce. Okay, so same thing, whatever I have explained, the same thing, that is client submits the job to job tracker on the name node. So here we will have a concept called a name node and a data node. So name node is nothing but a, I will explain, it will comes under HDFS Hadoop distributed file system. So name node is contains the structure of the nodes, that is metadata of the nodes. Name node and data node. Name node we will call it as a master node. Data node is nothing but it contains the actual data. So to execute the map reduce, we need data nodes. Data nodes contains actual data. Okay, so then name node it contains the structure of that data nodes. That's all. Okay, so here client submits the jobs to the jobs tracker running on the name node of the Hadoop clusters. Okay, so that is client is submitting the jobs to jobs tracker. That's all. Okay, so then job trackers, what it will do, it will generate the job ID, generates and returns a job ID for the submitted map reduce task to the client. Okay, so what you do, job tracker, it will assigns the job ID. Okay, so then this ID is used by the client or the name node to stop or kill the job if needed. Okay, this ID, whether I want to execute or delete, that one will be done by the name node to stop or kill For that, it is used this job ID. Then job resources such as jar files, meta files, input files to the MapReduce task are copied from the client to the HDFS that can be accessed by the name node as well as data nodes for processing. So here job resources will be allocated like jar files, meta files, input files to the MapReduce task to copy the thing. Okay, so then job trackers is now schedules the job to the task tracker running on different data nodes. Okay, so job tracker order, it will now schedules the job. You do this job, you do that job. Okay, so like that it will assign the jobs to task tracker. Okay, the task tracker, it will runs either map task or a reduce task assigned by the job tracker. It may assign map or it may be assigned reduce task, any task it may assign. Okay, so the task tracker, it will run depends on assignment of the job. Okay, once the job is finished, the result will be returns to job tracker. I have executed it, sir. I have executed this one, take this result. Okay, so it keeps sending a heartbeat message to the job tracker, indicate that data node is up and running. Okay, so it will send a signal. Heartbeat is nothing but a signal. So I am doing this one, I am doing this one, like that. It will send a heartbeat. Then job tracker collects the final result from all the data nodes and returns to the client. Okay, it will returns to the clients. Okay, so there is overall thing is a client will assign a job to job tracker, then job tracker, it will divide the job into a number of tasks. The task will assign to task trackers. The task trackers will execute the map reduce functions. Okay, using map reduce functions, it will execute all those things. Then results will send to job tracker. Then job tracker will give the results to client. Okay, so that is the concept of map reduce. Okay, so then when you come to I know that Apache framework, it contains two things. One is one is MapReduce framework. Another one is Hadoop distributed file system. MapReduce is nothing but it is used for execution of the data, and Hadoop distributed file system, it is used for storing the data. Okay, so here Hadoop distributed file system is used for storing a very large data sets running on clusters of commodity hardware. Okay, so here this Hadoop distributed file system for storing it is used for storing a very large data files. Okay, it is stored for very large data files running on cluster of commodity hardware. Okay, so it will be running on cluster of commodity hardware. Okay, so here it is mainly it is used to store the huge amount of data. Okay, it is a fault tolerant, scalable, extremely simple to expand. So it is fault tolerant. It won't okay, it won't tolerate any fault. Okay, it will be scalable and it will be extremely simple to expand. If you want to expand, it is easy to expand. Hadoop comes bundles with HDFS. Okay, so if it is Hadoop is there, means we should have an HDFS. If HDFS is there, it will have an Hadoop. Both things are combined. Okay, when Hadoop comes bundled with HDFS, a file system that manages, stores specific operations across a network of machines is called a distributed file system. Okay, HDFS, that is a file system that manages storage specific operations across a network of machines. Okay, if you are storing and managing one system, that is not a distributed file system. Okay, so here when the file system manages and stores the specific operations on across a network. So if in network we have a 50 or a 60 systems, so in that the file system manages the storage specific operations. So here I want to read from that one system, and I want to write on the systems, or I want to collect the data from all the systems. So here when I want to store the data on all the systems, so that is nothing but a distributed file system. That is, data is distributed among n number of machines. If 100 MB is there, 10 MB is distributed among 10 systems. That is a distributed file system. That is HDFS, Hadoop distributed file system, is one that such the software. Okay, if you are storing whole thing in one system, one hardware, that is not an Hadoop distributed system. So that is not a distributed file system. When the files or when the data is distributed among multiple users, okay, so at that time the Hadoop will, that one will call it as a distributed file system. The distributed file system is one type, that is Hadoop is one of the distributed file system. Okay, so same thing, Hadoop, it contains of two things. So that is name node and data node. So name node manages the file system metadata. Okay, metadata is nothing but a structure about data. So here in the name node, how many data nodes are there? So what is the size of each data node? So that type of that type of information is available in name node. Then data node stores the actual data. Okay, this data node stores actual data. So name node contains the structure of the data node, that is the metadata. Metadata is nothing but a structure of the data. So here this read write operations in HDFS operated at a block level. Okay, so read write operations is operated at block level. What is block? Okay, the data file in HDFS is broken into blocked size chunks, which are stored as independent units. Okay, so here, and the block size will be 64 MB. So here data will be stored in the form of block size chunks. We are block size. So each block should have a 64 MB. See here what is the size. Suppose when you want to read a data, so it will a minimum it will read one block size data. So one block when you want to read or write, so it will be the one block. One block is nothing but a 64 MB here. So that much of data it will be read or write. Okay, 64 MB. So it, the data files are distributed, they are in the form of block size called chunks. The chunk is this size, block size will be, it will be 64 MB. So this is the architecture of HDFS. This is the HDFS architecture. So however, the same thing, we will have two things, that is name node and data nodes. So these are the data nodes. In data nodes, we will have a block, one block, two block, three block, like that. We will have a block. Okay, so this is one data node. So in that data we have three data blocks. In another data, in another we have four data blocks. So these two things we'll call it as a one rack one, rack one. So in rack we'll have three data nodes. In rack two we'll have two data nodes. In rack one, in the rack one only we have three data nodes. In first data nodes we have three blocks. In second nodes we have two blocks. In third data nodes we have two things. Okay, so like that we will have a racks. Each rack contains a number of data nodes. In each data nodes we will have a number of blocks. Okay, so here we have a name node. Name node contains the metadata, that is name, files, replica, size, and all those things it contains. So whenever want to name node, want to write, whenever clients wants to read or write, okay, so here it will communicate with the communicate with the name node, and client will read the data. And whenever it wants to write, then use the client will using using name node, the client name node will insist to write which block and which place. So then the client will read the data to data node. Okay, so here this is the architecture of data, HDFS Hadoop distributed file system. In Hadoop distributed file system we have two things, so that is name node and data node. Name node contains the structure of the data, and structure of nodes, there's a data nodes, and data nodes contains the actual data. So here we have a rack size contains the data nodes contains the block is nothing but actual data. Okay, whenever clients wants to read it through that name node, it will read the data, and it will write to the data node. Okay, this is the architecture of data node.